Hello, everyone. My name is Rob Higurita, and I'm a Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS support. Joining me today is Tanya Pahuja from AWS Support. Can you give us a quick introduction, Tanya?
Sure. Hi, everybody. This is Tanya Pahuja. I'm a technical account manager here at AWS based out of Delhi, India. And I'm really glad to be a part of this show today. Thank you.
Thanks, Tanya, for the intro. And today we're going to be introducing you to the AWS Fault Injection Simulator, or FIS for short. We will specifically focus on how you can use FIS to create repeatable experiments and test the resiliency and reliability of your architecture on AWS. Before we get into the details, though, today, a quick note to the attendees online. Please make sure to use the right-hand screen, the chat window down there, to ask your questions today and share with us your thoughts throughout the episodes. Also, let us know where you're joining us from today. We really enjoy that. So we look forward to hearing from you all. And Tanya, could you go ahead and walk us through what we're going to be talking about?
Sure. Thank you, Rob. So, the title of the show today is Testing Reliability of Your Architecture Using AWS Fault Injection Simulator. So, we think the COVID 19 pandemic has proven to be the largest stress test of our technology infrastructures in generations. And a meteoric increase in internet consumption followed due to, in large part, to working and schooling from home. The chaotic early months of the pandemic have clearly demonstrated the value of resiliencies in production. And that's where we are going to focus today on certain modern approaches to testing and validating the application's architecture. So, talking about what are the challenges with distributed systems? Distributed systems have multiple components located on different machines and they vary greatly in implementations. Like, for example, a distributed system can be an offline system, that includes your batch processing systems or your big data analysis clusters, etc. There could be soft real time distributed systems. So, these are the critical systems that must continually produce or update results, but they have a relatively generous time window in which to do so. So examples of these systems include something like the search index builders or something that look for impaired servers or the rules for Amazon cloud compute. And third category of distributed systems are your hard real-time distributed systems. So these are often called request reply services. At Amazon, when we think about building a distributed system, the hard real time system is the first type that we think of. And the examples of such systems could be your front end web servers, the order pipeline, or could be the typical credit card transactions. So, as your distributed systems grow in complexity, so does the difficulty in predicting failures. Like the traditional methods of testing the distributed systems using unit or integration testings are not sufficient. And the failures of mission critical distributed systems can actually cause costly outages. So in 2017, like the 98% of organizations said a single hour of downtime would cost their business over 100K thousand dollars. That means one outage can cost a single company millions of dollars. And that's where company needs a solution to this challenge because waiting for the next costly outage is definitely not an option. But let's talk about how the distributed systems are complex. So, engineers working on distributed systems must test for all the aspects of failure from the client, network, and servers, as these do not share fates. So, and they must also ensure that the code on both the client and the servers always behaves correctly in light of those failures. Now, let's take a look at this example on this slide today. One round trip request reply actions always involves the same steps. That means, as shown in this following diagram, the client machine would send a request message over network to the server, and the server would reply with a message reply over the network back to the client. Now, those are a lot of steps for one measly round trip, right? Still, those steps are the definition of your request reply or your hard real time distributed systems. And there is no way to skip any one of them. Like, for example, if you look at this diagram, it's impossible to skip the step one, that means sending the message from client via network to the server, because the client must put message onto the network somehow. That physically, this means sending packets via a network adapter, which causes the electric signals to travel over wires to a series of routers that comprise the network between client and server. Now, this is separate from step two, because step two could also fail for independent reasons when the server is replying back to the client, such as server suddenly losing power or being unable to accept the incoming packets. And the same logic can be applied to the remaining steps as well. So we can see that there are several steps involved in the distributed systems, ensuring success with a simple operation. But there are several different permutations of possible failures as well on the simple distributed systems across thousands or millions of requests. Here in this slide, we'll talk a little bit more about what is chaos engineering and how it is related to the distributed systems. So, chaos engineering is a disciplined approach to identify those failures that we were just discussing in the distributed systems in the previous slide before those failures become outages. By that, I mean by proactively testing how a system responds under stress. Now, you can identify and fix failures before they end up in the news. So, chaos engineering lets you compare what you think will happen to what actually happens in your systems. By that mean you literally break things on purpose to learn how to build more resilient systems. You can think of it as a preventive measure to avoid larger compounding issues down the road. Now, testing the unknowns, here in this slides, the end goal which we have here is to improve the resilience and performance of the application and also uncover the hidden issues that kinds of expose blind spots. And if you look at that particular, the diagram which is shown on the left, there are typically 5 phases to chaos engineering. So it starts with a steady state, where you define a steady state as some of the measurable output of a system that indicates the normal behavior. For example, let's take a very simple example. You have a weather monitoring application that should be able to fetch the weather data and display it to the user within a certain tolerance. So that's what your steady state is. Now, the next step or the next stage is hypothesis. So, in this stage, you kind of create a hypothesis that this steady state will continue in a control group or, let's say, in an experimental group. And then the next step involves running that experiment. So, where it means introducing the variables that reflect your real world events to your application. For example, your server that can crash, or it could be your malfunctioning hard drives, which is not returning any data, or it could be any, the hard drive which is also returning an incorrect data, or it could also be the network connections which is breaking. So you kind of run those experiments by introducing the variables. And the last stage that we have in this chaos engineering process is verify. So after running the test, we verify whether or not the hypothesis was correct. That means this steady state continue through the experimentation when compared to the control group. So the entire chaos engineering involves testing the unknowns, and it's a very similar to the PDCA method, which is plan, do, check, act, or adjust. And it kinds of an iterative design, and it is a management method which is used in business for the control and continuous improvement of your process and products. Now, in this slide, what are the challenges that we see or observed in chaos engineering? So, there are many open source tools for chaos engineering, and we have to stitch. At times, we might have to face the challenge where we need to stitch together different tools. However, the processes for these tools may be complicated, and the support options may be very limited. And it could also happen that the additional scripting may be required, which can lead to issues in getting up and running with chaos engineering. The other challenge that we could see is the compatibility of the required libraries or the agents for these open source tools. So, this could be another challenge that we can face with chaos engineering. We can also see that, if you're performing testing in productions, or let's say if we have a high profile environment, we want to be able to limit the extent of the potential issues from an experiment, but without the guardrails in place, the experiment can go sideways very quickly, right? And they might can affect the rest of your environment and can actually cause an outage. Like there is always a difficulty to ensure the safety. And the other challenge that could happen is, we want to be able to simulate failures in software as well as hardware. But we might face challenges with just chaos engineering alone difficult to reproduce the real world events. For example, you want the multiple server failures at once, but you also want an application microservice failure. So these are some of the challenges that we might often observe with just chaos engineering alone. So before we go on to the next slide, I would just like to check with Rob. Rob, do we have any questions from our audience today?
Hi, Tanya. Thanks for what you've been covering so far. We do have a question that came in from the audience from JibJab06. Thanks for your question. They wanted to know, how do I prevent issues in my production environment when using chaos engineering? Is this something you're going to be covering today or maybe in a little bit?
Yes, sure. So this is what we are going to analyze in just our upcoming slides, because chaos engineering is just a process of stressing the application in testing and the production environments, right? And how we're going to prevent those issues is something that we are going to discuss in the upcoming slides. We would discuss on, how do we analyze the steady state behavior, and how do we build an experiment hypothesis and then execute that experiment using the AWS fault injection simulators, which is the topic of the episode today. And also, Rob would show a quick demo that would implement, how can we address those weaknesses in the application.
Great. Thanks, Tanya. Back over to you.
So here, the fully managed chaos engineering service. So with AWS, we have AWS fault injection simulators, which is a fully managed chaos engineering service. And it is designed to be easy to get started and also allow you to test your systems against real world problems. So whether they are simple, like, just stopping an EC2 instance, or it could be more complex as well, like the other real world problems that we see in the applications. AWS Fault Injection Simulator fully embraces the idea of safeguards, which is a way to monitor the blast of the experiment and stop it if certain alarms are set off. And then getting started with Fault Injection Simulator is actually designed for you to be as easy as possible. Then the other thing is, you can leverage the AWS Management Console, or you can also use the AWS Command Line Interface CLI to configure your fault injection simulators, and you can also use the pre-existing templates that we have to get started in minutes. And these templates are just in JSON or YAML format, so you can share with them with your team. After you've started with fault injection simulators, you can run experiments either in sequences or in parallel as well. So that's another flexibility that you get with AWS fault injection simulators. When I say you can run experiments in sequence, that means you can run the experiments which is used to test the impact of gradual degradations. For example, a gradual increase in the CPU or the memory utilization. And similarly, you can also run the experiments for parallel experiments, like, you can test the impact of multiple concurrent issues, which is often the case in a real world outage. So you can target all levels of your system across the host, your infrastructure, or the network. And the faults are really happening because they're injected at the service control plane level. So they're as close to as the real world problem that you can see with your applications. And the other thing that AWS Space offers is safeguards. That means, you have a safeguards act just as a stop button. and that allows you to monitor the blast radius of your experiment and make sure it's contained, and that the failure created in the experiment is kind of rolled back if the alarm goes off. And it also, fault injection simulators also leverages fine-grained IAM controls so that you can use to determine the fault types and the resources that can be affected. With this, I would like to hand it over to Rob to talk more about high level on the AWS fault injection simulator.
Hey, thanks, Tanya. I appreciate that. So, yeah, we're going to talk a little bit about AWS Fault Injection Simulator. I did want to address, we are having a great chat with user Nick Levesque, I think is how you pronounce the username, really discussing about the overall barrier to entry as far as, adopting into doing chaos engineering and maybe the tweaking and never actually making progress. And I think that's the important thing of what kind of Tanya was referring to a little bit was defining that scope for each test, right? Are you testing for performance wise? And so that's where you're going to leverage your chaos engineering to actually implement, maybe API throttling that we'll talk about later to see how your application responds and really have your focus on that whole entire hypothesis, right? And like go around that whole life cycle for it to verify, yes, everything's great there. Or are you purely focused on looking at something like reliability and resiliency, and you're going to test what happens if something actually drops out from your environment, like an EC2 instance or such. So don't let the unknown be a barrier entry in chaos engineering. We will provide some links as well with some other items like how to automate test or how to run these tests and services like EKS and such if you're using those. We'll also see in the demo a few different ones that we'll get to here on that we have just some kind of tutorials on that will hopefully get you started. But there's a lot of great benefit from chaos engineering. So I just wanted to address that from the chat there. But back to what Tanya was mentioning, we have AWS Fault Injection Simulator, and it's our fully managed service. So I want to spend a little time just kind of going over a little bit of the components, and then we're going to jump into a demo in the console and show you a little bit, just a really simple experiment on how to get started using it. So as we can see here on the screen, we've got some controls that we can implement through identity and access management to restrict who can access Fault Injection Simulator, what resources it can interact with and such, really to help you get greater control. The nice thing is this is all either accessible via the console or the API to create your experiment templates and run these in a really repeatable fashion. That way you're not doing chaos engineering in a previous manner where someone would just go in and be like, all right, I'm going to stop the instance. Or if you don't have ideas on what you can actually leverage or implement with chaos engineering, we have a whole bunch of predefined actions that you can leverage as well that are going to be able to be used against a variety of AWS resources. So we'll start our experiment, stop our experiment either through the time base that we're going to do this or through a stop mechanism like a CloudWatch alarm. So you may have your application performance metrics that you're using to kind of analyze as this chaos engineering is happening in your environment and making sure that you have a certain threshold that you've seen before that may impact your production environment that you're going to set your CloudWatch alarm to stop the experiment before you get there so you don't actually see performance impact. And that gives you a learning point to go back and review how did that respond and happen throughout the environment. So in order to get an experiment and actually run it, we have experiment templates that we can use to be repeatable, but we're going to put elements into those experiment templates, including your actions and your targets. So experiments is what we actually run to do our chaos engineering. Our template is our kind of base of it. And inside, like I mentioned, we put these actions and targets. In actions, you'll see here, we have kind of when we get to the demo, we have a list of a few different ones, and we're just going to use an easy EC2 stop-start test with it. But you're going to define your actions. And then once you define those actions, it's going to have to go against targets. And targets are going to be your AWS resources that you're specifying to, set this activity against. Again, in our demo today, we'll just be using an EC2 instance to show you how that works. But those are going to comprise and make up our experiment template that we can then use to repeatedly rerun within our environment and be able to leverage the AWS Fault Injection Simulator. As I mentioned before, can do a number of different things as far as injections that we can have into your AWS environment. That could be API throttling. If you're using ECS, it could be the termination of a worker. It could be an EKS where we're going to stop one of the worker nodes within your cluster, or we're actually going to interact with the pods and remove an application from your EKS cluster and see how things respond, right? So a lot of different tests that we have available that are just built into the service before, where you maybe would have had to script this all out yourself. AWS Fault Injection Simulator makes it easy for you to get, in there and actually starting to implement and do things. So even as simple as testing your, failover of a multi-AZ RDS database with your application to see what the latency looks like. If you've got your normal monitoring set up for this, you could test that failover mechanism and see how long does it take for it to actually fail over, what impact do we see on an application in a really controlled, repeatable fashion. So, of course, we're always building for our customers, and so there's more services and such that are going to be coming that will be added into Fault Injection Simulator, so keep your eye on our product page for that. With that, we're going to jump over and look at a demo of what it's like to set up AWS Fault Injection Simulator for a very basic template that we have in our tutorial to get you started in going through things. So let's switch over to this. So we're going to go over just something that's found in the AWS Fault Injection Simulator documentation, so in our tutorials, and be able to implement and use that. So in order to get started, AWS Fault Injection Simulator, as we mentioned before, is a fully managed service that enables you to perform fault injection experiments within your environment, right? So nice, fully managed, easy for you to get up and get running with. And we have some tutorials. We have concepts and such that are built in that you can read about. We're going to cover just the first tutorial that we have here, which is test instance stop and start. This is really handy and useful for you in things like if you've got autoscaling deployed in your environment, and you're going to be leveraging that to make sure that when I stop an instance, something happens. A response to that, right? We also have some for running CPU stress tests and testing spot instance interruption within your environment. And if you're, just getting started with EC2 spot, potentially it may be something that you really want to test to understand how your application works with a spot interruption happening. And if you're not familiar with spot interruptions, it's basically every 2 minutes or at a 2-minute notification, it will let you know that it's going to reclaim an instance. And you may just want to test for that. So Tanya, I don't know if your customers have used Spot or not, but I just wanted to ask and see if you had, some information that maybe you've had experience with your customers in EC2 Spot.
Yeah, there are many customers of that I've been working with kind of uses Spot instances, and I think when using Spot instances, you need to be prepared to be interrupted. So with Fizz, you can actually test the resiliency of your workload and validate, that your application is reacting to the interruption notices that EC2 sends before terminating your instances. And in fact, you can target the individual Spot instances as well. Like, also you can also target the subset of instances in clusters managed by services that tag your instances. So with just few clicks in the console, you can just set up an experiment, as Rob was mentioning, and that triggers the interruptions on your Spot instances. Additionally, you can leverage the fixed experiments to run more complex scenarios with additional distributed system failures. And I think one of the demos which Rob would be just showing you here, and that kinds of enables you to create the real world conditions necessary to find those hidden weaknesses, as we just mentioned.
Great, thanks, Tanya. Appreciate that. So we're going to jump in here and just show you one of the experiment templates that we have or tutorials that we have in order to be able to get up and running with Fault Injection Simulator. And so I've already gone ahead and taken care of a few of these prerequisites that we have here. I've already launched a couple of these instances and created an IAM role and such. And if you're not familiar with how to do some of these things as far as the IAM permissions, we have some links in here that will be able to help you get up and started and get running with the necessary IAM permissions to get FIS working. So you don't have to be an IAM expert to start using it. And we're going to run through basically a lot of these steps here that we see in this experiment template. We're going to go in and open the FIS console. We're going to do the experiment template, choose some instances that I already have created, and we're going to run a few of these stop-start actions against them. Again, this is really helpful if you're going to be testing against things like making sure that you have an auto-scaling group. Maybe you've got multi-region that you've got deployed, and you've got Route 53 and some health checks and such, and you want to make sure that if an instance goes down, it's hopefully not a single instance that you have out there. But if it is, because you're leveraging multi-region, right, that it, fails over for you accordingly and works. So that's what we're going to kind of run through. We'll go down here and you can see, Tanya was mentioning before that you have the option of JSON YAML for your output that you can have from your experiment templates and such, so that you can work with to define and create these. And you can actually export this, use this to put in your own version repository so that you can keep iterations of it to use within your organization if you want. And so this is just kind of an example of them. As we get going through, we'll be able to run through here and start the experiment, track the experiment progress. This is probably the really important part, right? You want to make sure that you understand what's happening within your experiment, how things are reacting within your environment. You can have your monitoring, your stop state and such. As we get going through today's demo, since it is just a demo environment, I don't have stop state because it's not a production environment or anything. And then we'll go through and we'll be able to verify the experiment result and take a look at it. And I'll show you what that looks like as well, where we can see kind of our timeline and see how things interacted and kind of, met their timeline to stop and start. And if you are going to try this in your account afterwards, we of course got some cleanup steps in here as well, so that we have make sure that you get rid of the resources in the end. So as we can see here in the console, I have two demo instances that I just named FIS Demo Instance 1 and Demo Instance 2, just to make it really clear which ones they are. And those are going to be our targets that we're going to have for our actions in our experiment template eventually here. So we'll see that we have just a couple of these. They're both running in the same availability zone right now. Again, just a demo environment. This is real life. It may be in a couple of different availability zones. I chose a couple T2 micros to be in the free tier for this experiment. So again, nice and inexpensive, but we're going to be able to use these instances to kind of jump in and look at some of our experiments and experiment templates. So we see here, this is the AWS Fault Injection Simulator console that we're going to start off with. And we're going to see that I already have an experiment template that I created ahead of time. And ran and tested. The most reason why I did this is because if we were to run through the whole process, it waits for 3 minutes after it stops an instance and then goes another 3 minutes before it does the next group of them. And we'd be kind of sitting here waiting, staring at the screen for a little bit. So I already reran the templates and I'll kind of walk through the timeline a little bit. I will start it to show you what it looks like as we get started and what it looks like to create one here. But just want to let you know, I won't make you wait 6 minutes to just watch my screen. So as we get into creating a template itself, an experiment template, we define name of it, right? A little bit of information on it, the role that's going to run things for us. Since I already have these roles created, I can just choose them from my drop-down box. And then I mentioned we have these different components where we're going to add actions and targets to these and be able to leverage these different resources. Stop condition. I mentioned before, I don't have any created for mine. These are just a couple other CloudWatch metrics that are created or CloudWatch alarms. But if you wanted to set a stop condition, so say your resources or CPU starts to spin out of control, or you start to notice a response time from your website that's greater than X milliseconds, and you want to stop the experiment because you do not want to actually impact your production environment, you can set up a CloudWatch monitor, use that to be your stop condition, and that way you don't have to go in there and quickly try and stop the experiment. It will automatically stop for you. This can be helpful in a link that I provided as well earlier that has how you can automate using Lambda with your CI/CD pipeline using Fault Injection Simulator. You can have these stop conditions in place. So if you're going to just randomly have these run off as automated tests for you to verify reliability, you can have these stop conditions in place to prevent anything from happening. We can, of course, add some tags here if we wanted to into our resources, but since I already have a template and tags aren't going to really be helpful in this instance of usage, I'm not going to select those. But those are kind of all the components we're going to start off. So we'll go in and eventually here take a look at my existing resources that we have created inside of an experiment template and see what that kind of looks like. So jump back here. And we'll go into this experiment template and take a look at what it looks like with everything kind of defined. So I just named it an FIS EC2 experiment. Nice and simple, easy name for today's demo. We can see the role that I mentioned before that I have created. And we can see some of the actions here. And these are the things that I've already defined. And I'll show you how to kind of define these as well. But this is basically in the experiment that we have in the tutorial. It's basically going to have you stop one of your instance. And you can have this randomized. So we can set a target group and we can say, put this batch of instances in by choice or by tag. And we can say against this group of instances, say, stop one instance. And that way it'll just randomly stop one. One nice thing that you can do is you could say, set a group of instances that you want to be marked as chaos ready. So you can tag those and have them listed as chaos ready. And that way, as you run your fault injection simulation against it, you have that pool of EC2 instances and you say stop one. Say you have 3 out of your 10 instances that are actually chaos ready. Well, it's really only going to run against those 3, even if you added all 10 to the stop instance group. So we have our different determinations of stops a single EC2 instance, my description for it. It's going to do an EC2 instance against my demo EC2 instance target group. And I have the timeline set to at 3 minutes is when it's going to take that first action, or when it's going to wait basically for that. So it's going to kick off when I kick off the experiment, stop one of my instances, wait 3 minutes. And then I have another action. So this kind of similar to what Tanya was talking about before of going into running them either simultaneously in parallel or in series of each other. You can kind of have these different experiment steps run one after the other so that you can see what happens. In my next iteration step here where I have stop one instance, now my next step after 3, it's going to stop the instance, restart it, and now we're going to see what happens if I actually stop both instances in my target group. And so we would see after 3 minutes that it would go through and do this. And we'd see that we have these demo EC2 instances for details, and that it has some various selection mode items. That selection says, hey, count 1. So even though I have 2 resources, as you can see by the resource orange number below that says 2 resources, I actually have a count that says actually only stop one of those 2. And then the next group, we can say that I have both instances is what I've described it as. And what it's going to actually do for selection mode is all. And that means that whatever I've put in there, it's going to stop both of those resources. So that way we can have the same groups of targets stop different ways, just depending on how we choose to implement the actual chaos side of things as we go through it. So mentioned before, we're going to have a timeline of items here. And this timeline is going to be really helpful for you to be able to kind of get started and look to see, that 3-minute mark and make sure that things happen. And I'll show you what it looks like in an actual completed experiment that we've gone through before already. But as we can see here, we've got this different timeline of events that we can overview, and we can see stop instance, 1, and then we can see this other one here where we've got the next sequence that's going to start after our first 3 minutes and going. Being able to watch your timeline is kind of part of when you're doing experiments. You can make sure that your steps are happening as you're going through things, and you can kind of just watch it and give you a little overview. From these existing templates here, as we can see our experiments, I can update this experiment template. I can start it. If I want to do this repeatedly here from the console, I can manage the tags, or I can get rid of it if I find this experiment template wasn't what I wanted. If I chose update, I could create a new iteration starting with it, say this was close, but I want to make a few modifications to it and just create a whole new template. We can do that as well. So if we go into update, we can see here more in detail some of the items that we have defined within this for stop instance, start instance, or both instance for targets. As mentioned, I just have the same target group created. It's just that I have different conditions in my actual actions that take effect against this one target group item. So it's just helpful because you don't have to define a whole bunch of different groups. You can just tell it to respond to things differently on these actions. So that's kind of our overall thing here. And we got those tags and deletes, right? So if I want to get rid of this one, I can clean it up afterwards. So if we didn't want to keep it, we didn't have to keep it in the long run. So timeline's really helpful here. Did want to stop there as we're kind of going through overall in the demo and talk a little bit kind of like the benefit of the timeline and the stop start instance and responding to things, right? We run, if you've ever been to reInvent, or even if we've been able to make one of our public game day events, we do game days for AWS. One of them is called Microservice Madness, and part of it is actually has some chaos engineering built into it. Existed before Fault Injection Simulator, but what it would do is it would essentially get rid of an EC2 instance in the environment. And during the game day, you have to go in and, bring that web service back up so that you can continue playing the game. One thing that, as TAMs, we've kind of learned with our customers and heard from our customers is they get a lot of great experience from the game days, and especially this chaos engineering component that one of my customers, when they were working on it, they had their instance go away as part of the game day. And they spent time manually rebuilding that instance, getting it all back up and working, choosing the new AMI, reinstalling the web service that needed to be on there, getting everything back up and running. And then 2 minutes later, that instance went away again. And they were like, great. The biggest thing we learned from today is we spent all this time manually recreating that instance and then forgot to create an image of it so that we could quickly and easily reproduce that web service, or basically take that instance and put it into an auto-scaling group or something so that when it goes away, it can come back. Tanya, I don't know if you've had customers before that have run game days with you and had similar experience, but that was definitely an interesting story that I've had with, one of my customers benefiting from chaos engineering.
Yeah, no, I agree. I think there are multiple, portfolios of game day that I've also run for my customers. And I think, as Rob mentioned, microservices madness being one of them. There is also kind of something which is focused on chaotic commencement. So this kind of focuses, the game day focuses on teams using different AWS services such as EC2, ELBs, or CloudWatch, and basically these kind of game days are more focused on evolving the architecture which is receiving traffic. So just talking about my experience of running the similar kind of game days, focusing on chaos engineering for customers, seeing the teams and participants receiving points for being able to respond by, bringing an instance up or terminating an instance with, points appearing on a scoreboard visible to all of them. That kinds of just creates a friendly competition, is because teams walk in, together to attain the highest scores, and then points are attributed to teams that responds to queries more consistently and quickly. So while running the game days for the customers, I could actually see the customers and the participants, working in teams to, responding, doing all those of excessive amount of infrastructure testings, real time and in a gamified ways. And, they might see their score decreasing. So the game just keeps on going, or typically for, they last for, varying from 3 to 4 to 5 hours. But the several challenges that gets thrown at players throughout the day just keep them on their toes.
Mm-hmm.
And this is so exciting to host such game days events for the teams to collaborate and then, testing their problem solving. So if you have already not participated in any of the game days, and if you have TAMs, go tell them to host one game day for you, or also you can join us at the reInvent. So we'll be very happy to, host it and give you that gamified experience for both operations and DevOps.
Great, thanks,
Thanks,
Sonia.
Rob.
Yeah, no problem. So yeah, they're really handy, lots of fun. So great little events to be able to attend if you have enterprise support and such, and can reach out to your technical account manager. All right, so I'm going to show you here as we go through back to the video, or back to this, on what it looks like to run through the overall instance in a completed process, right? So I wanted to show you here just kind of what a completed timeline looks like when you're going through the environment, and be able to kind of see, as we run this experiment, what a completed one looks like. This can be used here for historical purposes to go back and be able to reference to see, did this experiment succeed last time? Did it follow our checks? Really, like Tanya's mentioned, build a plan that you're going to use. And as I mentioned before, have a target kind of goal that you're going to be able to leverage and do this for each experiment that you can be running. So got a lot of stuff that we can do here throughout things. So I'm going to jump back over to my experiment template here. And we're going to be able to go in and start this experiment. So we saw what it looked like before completed. I want to see, just show you what it looks like when you kick one off, and just kind of get it started in the process as the last part of our little demo here for today. But as we go to start an experiment, this little box is going to come up, and it's going to give you a little warning message, right? You're about to start an experiment, and this experiment has actions that it's going to take against the resources that you define. So you want to make sure that either these are going to happen. If you schedule these, like I said, using automation, you want to make sure you obviously know when you're going to do those. But if you're going to manually be doing this, and it's maybe your first time testing through chaos engineering, you might do it in one of your other environments other than production. But if you're going to be running this in production even still, and you don't have a stop condition, you want to make sure that you know that these experiments are starting. It's going to make you type start in here. This is just kind of a one last little safeguard for you before you actually start experiment, to know that I'm about to impact some resources in my environment. Let all the necessary parties know. We'll type start, and they'll be able to start our experiment, and we'll see that we now have these in pending state. And we'll refresh here in just a second, but these are going to sit in pending for just a moment, and we'll see one of our EC2 instances here go from running. Let me refresh again, and it'll go into stopping. And so it has chosen that instance to stop. And if we come back into our experiment, we'll see that it's now running. So we went from pending to running, and we now see that that action is happening against our resources in AWS. So if we check our instance again here, eventually it'll go from stopping to stopped. And if we have our application monitoring and our website up and running, we may start checking it now to see, hey, is everything working, right? If we had a web server that was hosting a couple different websites, we'd want to make sure that all those websites are working. We've got, CloudWatch synthetic monitoring set up on those. We go check those synthetic monitors, make sure that we've got performance monitoring for the application side. Maybe we're going to start tracing stuff in X-ray to make sure that, we're not seeing any impact in those tools and be able to check here. So that's what we'll kind of see as we get that instance to stop, where we're going to really want to start making sure that we're looking at all of our visibility and observability side of things to understand, what's happening in the environment now that we stopped that instance. And so even though my instance is stopped, we can see here that we've got running and pending. And it's going to stay in pending for this other one for a little while because we do have that 3-minute mark set. So this is where I mentioned before, I wasn't going to make you wait for the 3 minutes to finish, then the other 3 minutes to go through again. And why we kind of looked at the overall timeline of completion before on the experiment. And kind of showed you what it looks like on the timeline wise to be able to go through things and see, how overall you can leverage Fault Injection Simulator and get started really quickly to have it actually take action against your resources, whether it just be that stop of an EC2 instance, or as we mentioned before, in the different, API throttling, the RDS multi-AZ, the EKS pod, deletion for one of your application, and ECS. We have 3 tutorials that you can get started with, and then we have several blogs that we'll post some additional links to and stuff here as well to be able to, give you some examples of how you'll be able to get started in testing some of these items. So, Tanya, I just want to check, do you have anything else that you wanted to add so far?
No, I think I'm good. You kind of already covered, Rob. But yes, I think the one thing that we kind of just do in is that there are several things you need to think about before using FIS. But as Rob was mentioning, right, we need to also focus on the fault injection experiment matures. You can just introduce fault injections to continuously assess the resilience in the production environment. And also, once your experiment is over, just evaluate if your application resiliency is in line with your business and the technical expectations as well, because that's very important. So yeah, these are the things that I would just like to mention.
Great, thanks, Hannah. And we did have a question that came in from the audience here just a second ago. I'm going to just address here. So Elijah Cahill wanted to know, what is the level of support do I have during such an experiment for my business? Is it possible to get a team from your side on standby? And so just to address Elijah, it's going to depend on what level of support you have from AWS. Fault Injection Simulator is meant to be a fully managed service that you can implement and use within your environment to test. Your team is going to know your application itself best to understand what kind of metrics you're going to be tracking against for performance-wise. So that way you don't actually have to use AWS support necessarily. If you did have questions and such, if you have developer support, business support, enterprise support, you can open a technical support case for questions on Fault Injection Simulator if, say, something isn't working the way that you anticipated it to work in your experiment as the actual execution of the experiment, right? But we won't be able to provide application support on your application itself. We will be able to provide support on the Fault Injection Simulator service itself. All right. So we don't have any other questions right now from the audience, but that concludes kind of our demo overall of the AWS Fault Injection Simulator and the service. So everyone, today we really looked at the AWS Fault Injection Simulator, a managed solution to help you get started with chaos engineering in your AWS environment. If there are questions that weren't answered today that we missed at all, please feel free to post them in repost.aws. Email us any feedback you have to awssupportsyou@amazon.com. We do want to hear from you, so please shoot us an email and let us know what you'd like to see on the show. And if you join us next week, we'll be discussing more about improving reliability and resilience in AWS with one of our principal reliability engineers. So thank you for joining us at AWS Supports You, and happy cloud computing, everyone.